Hello everyone, I am Sheikh Sana Kausar. My roll number is 21BQ1805L5. I am going to discuss about Kruskal's algorithm. In this Kruskal's algorithm, here we are also see the complexity, working and example of Kruskal's algorithm. But before moving directly towards the algorithm, first we should understand the basic terms of the Kruskal's algorithm, that is spanning tree and minimum spanning tree. A spanning tree is a subgraph of an undirected connected graph. Minimum spanning tree. A minimum spanning tree can be defined as the spanning tree in which the sum of the weights of the edge is minimum. The weight of the spanning tree is the sum of the weights given to the edges of the spanning tree. And now let's see the main topic, that is Kruskal's algorithm. It is used to find the minimum spanning tree for a connected weighted graph. The main target of the algorithm is to find the subset of edges by using which we can traverse every vertex of the graph. It follows the greedy approach that finds an optimum solution at every stage instead of focusing on a global optimum. But how does Kruskal's algorithm work? Let us see. In Kruskal's algorithm, we start from edges with the lowest weight and keep adding the edges until the goal is reached. The steps in Kruskal's algorithms are listed as follows. First, sort all the edges from low weight to high. Now, take the edge with the lowest weight and add it to the spanning tree. If the edge is forming the cycle, then remove the edge and reject that edge. Continue to add the edges until we reach all vertices and a minimum spanning tree is created. The applications of Kruskal wiring among cities and can be used to the lay down LAN connections. Example of Kruskal's algorithm is working along example. Let us see the example of some weighted graph. Kruskal algorithm can work on both weighted and unweighted graphs. Now we are seeing the example of the weighted graph. The weight of the edges of the above graphs are A to E is 5, A to B is 1, A to C is 7, B to C is 3, C to D is 4 and A to D is 10. Now we are sorting the weights of the graph from ascending order. Then first add AB to the weight 1 because AB has the least weight, that is 1, so it must be added to the graph. And next we should add ED, then CD, then AE, then AC and then AD. But let us see if all of them will be added to the spanning tree or only some of them will be added, because some will be rejected if they are forming the cycle. Here in step 1 we are adding AB edge to the weight 1 in the minimum spanning tree. It is selected because it does not form any cycle. In step 2 add DE with weight 2 in the minimum spanning tree and it will also be selected because it is not creating an edge. Now in the BC will be added to minimum spanning tree which is of the weight 3 and it is also added because it does not form any cycle. Then add on CD to the minimum spanning tree because of its weight is 4 which is less. The weight is 4 which is less. Then next in step 5 add pick edge AE with weight 5. Including this edge can create a cycle, so it is discarded. In step 6 pick the edge AC with weight 7. Including this edge will create a cycle, so discard it. Step 7 pick the edge AD with weight 10. Including this edge will also create the cycle, so discard it. So the final minimum spanning tree obtained from the given weighted graph is by using Kruskal's algorithm is A to B, B to C, C to D, D to E. Only the smallest weight is added. The cost of the minimum spanning tree is sum of the weights of all the edges. The total edges will be n minus 1 of the spanning tree. On adding AB plus DE plus BC plus CD to know the min cost of the spanning tree, we get 10. So the minimum cost of the spanning tree which we have taken is 10. Now let us look to the algorithm. Create a forest of F in such a way that every vertex should be adjacent. Then create a set E that contains all the edges. Repeat step 4 and step 5 until E is not empty. And if the edge obtained in step 4 connects with step 5, discard the change. Now let us know the time complexity of Kruskal's algorithm. The time complexity of Kruskal's algorithm is O of E log E or O of V log V, where E is the number of edges and V is the number of vertices. Let us look take an example of Kruskal's algorithm, let us discuss a program in C++. Here, header derivo stream and hashtag algorithm. Now we are creating the namespace standard and we are giving count max equal to I e4 plus 5. Here e4 is the number of edges and id of max nodes and edges void int, and we are printing the normal weights of the edges. Now we can see here int root of int x, while id of x not equal to x, id of x equal to id of x, x equal to id of x. Return x. If the edge has smallest weight, then it will be included in the minimum spanning tree, otherwise it will be discarded. In this way we can create a minimum spanning tree in Kruskal's algorithm. Hope you understood. Thank you.